I see just back here with some trig properties of special angles, radians, and identities. And so we'll start with first going on special angles. And so we need to understand the kind of special angles that we deal with, because we call them special because there's no need of using a calculator whenever you are dealing with them. So the special angles that we really need to survey is 30 degrees, 60 degrees, and also 45 degrees. So we'll start with the 45 degrees and see how we get the angles on there. So when it comes to 45 degrees, for us to get that special angle, the kind of triangle that we use is an isosceles triangle. Now this is a type of special isosceles triangle where one side is 90 degrees. Of course, we know that for us to call it an isosceles triangle, that means two sides should be equal. And so what we are having here is, okay, so we are saying one side is going to be 90 degrees and the two sides are equal. And so since the two sides are equal, that means even the lengths are equal, even the other two angles are the same. So having this as 90 degrees, that means the other two should also give us 90 degrees, and so they divide into 45, 45 each. So for this kind of triangle, to get the special angles associated, we take each side, with these two sides which are equal, to be 1 unit. So this will take as 1 unit, even the other side will take as 1 unit. Now using the Pythagoras Theorem, how do we get this other side? Let's call it x. Now that is the hypotenuse, and so x squared is going to be equal to the sum of the squares of the other two sides. And so we're going to find that this is going to give us x squared being equal to 2, and so x is going to be the root of 2. So the other side which is not given is the root of 2. So that gives us the root of 2. And so understanding this, that means when we're talking about these special angles, of course we know our trig ratios. The trig ratios that we have got sine, we have got cosine, and then we have got tan. Now each of these have got their opposites. The opposite for sine, or the reciprocal for sine, is cosec. The reciprocal for cos is sec. The reciprocal for tan is cot. So all these are short forms or abbreviations, and so we are going to use a special SOHCAHTOA to be able to determine all these special angles that we are having here. And we start with a sine of 45 degrees. Now from what we can see, a sine is opposite over a hypotenuse. So if we take this side, which is here, the opposite is going to be that, the hypotenuse is going to be that, and so sine 45 is 1 over root 2. And then we go to cos 45. Then cos 45, cos, we can see it is adjacent over hypotenuse. The adjacent is that, the hypotenuse is that, if we are taking this angle. And so that is going to give us, the adjacent is here, the hypotenuse is here. Okay. So that is also going to give us 1 over root 2. Going now to tan 45. So tan 45 gives us opposite over adjacent. So the opposite is there, the adjacent is there. 1 over 1 is a 1. So tan 45 is a 1. Now if we take the reciprocals, of course we've just looked at sine and cosine. The opposite for sine is cosec. So that means cosec 45 degrees is going to be, we're just going to reciprocate this, because we know that cosec is the reciprocal of sine. So that gives us root 2 over 1, which is simply root 2. And then the opposite for cosine is sec. So that means sec 45, we're also going to reciprocate. 1 over root 2 becomes root 2 over 1, which is simply root 2. And then the opposite for tan is cot. Now cot 45 is going to give us, what is the reciprocal of 1? 1 is the same as 1 over 1, and the reciprocal of 1 over 1 is simply 1 over 1, which is simply 1. So really nothing changes for that one. So these are the special angles when it comes, these are the special ratios that we need to get to understand when you're talking about 45 degrees. So there's no need really using a calculator when we are dealing with these. So if we go to 30 degrees and 60 degrees, we use the same triangle. The kind of triangle that we use is an equilateral triangle, a triangle where all the sides are the same. Alright. Now, since all these sides are the same, so that means that even all the angles which we have here are going to be equal. Now, this is a triangle, and the sum of interior angles is supposed to give us 180 degrees. That means this is going to be 60, the other one is going to be 60, the other one is going to be 60. And we take each of the sides to be 2 units. And so what we do is we are going to cut this triangle into 2 halves. So we cut it on the middle. So notice that if we cut on the middle, what we formed is a right angle triangle. So this makes 90 degrees. And so this now becomes 30 degrees because we've cut the 60 into 2 halves. So we're going to remove one part because they're all the same. Now notice that since it was 2 units, we've cut it in 2 halves, then this becomes 1 unit. So we remove one part to remain with only one part. In that manner. So the hypotenuse is there. And then we have got one side. What of the other side? Let's call it y. What would be the value for y? So for that y, one side, which is a shorter side, is simply you get the hypotenuse, to square it, and then you remove the other side also square. So that will give us y squared is equal to, I mean, this is a 2. Okay, it is a 2 there, that's the hypotenuse. So 2 squared is a 4, minus 1 squared, which is a 1, so that gives us a 3. And we want to remain with y, so we're going to square root on both sides, and so we're going to find that y is the square root of 3. So this side is equal to the root of 3. So if we start with 30 degrees, we say sine of 30. Sine 30, as we can see, sine is opposite over adjacent from SOHCAHTOA. The opposite to 30 is that one. Sine is opposite over hypotenuse. The hypotenuse is there, so it's 1 over 2. And then if we go to cos 30, so cosine of 30 is going to give us adjacent, which is there, over hypotenuse, which is there. So that is root 3 over 2. And then if we go to tan 30, so tan 30 is opposite over adjacent. The opposite here, the adjacent is here. So that is 1 over root 3. So that is about 30 degrees. Now let's go to 60. What of sine of 60 degrees? So sine 60 degrees, as we can see, 60 is here. Sine is opposite over hypotenuse. Opposite is there. The hypotenuse is there. So that gives us root 3 over 2. And then the cosine of 60 degrees. Cosine is adjacent. The adjacent to 60 is that over hypotenuse. So that gives us 1 over 2. And then tangent of 60 degrees. First opposite over adjacent. That is root 3 over 1, which is simply root 3. So these are the special angles, the 3 first trig ratios. If we get their reciprocals, the reciprocal for sine is cosec. So what we are saying is cosec of 30 degrees then becomes 2. If sine of 30 is 1 over 2, then cosec of 30 will be 2. And then the opposite for cos is sec. So sec of 30 gives us what was on top comes down, and what was down comes on top. So it is 2 over root 3. The opposite for tan is cot. So cot of 30 gives us root 3 over 1, which is simply root 3. If we go to 60, the opposite for sine, of course, is cosec. So cosec 60 is going to be 2 over root 3. We just get the reciprocal of that. And then sec, which is the opposite of cos, becomes 2. And then cot 60 becomes 1 over root 3. So then that will be the trig ratios. and also the values. Alright, so we see that there is no need for us to use a calculator when we are dealing with these kind of angles. So that is how we get those special angles. And so we should just be able to understand in which quadrant is each trig ratio positive, in which quadrant is it negative. So if we come on our Cartesian plane, now in this case we are going to get them as quadrants. We are going to call this as the first quadrant, this as the second quadrant, this would be our third quadrant, then this would be our fourth quadrant. So in the first quadrant, all trig ratios are positive. Sine is positive, cosine is positive, and then tangent is positive. The second quadrant, only sine is positive, the others are negative. In the third, only tan is positive. In the third, only cos is positive. So we see that it is only in the first quadrant that all the trig ratios are going to be positive, and then in the others it depends with which quadrant you are in. Now before we even look at more about quadrants, we need to understand the types of angles. So a first angle that we want to talk about is an acute angle. So acute angle. So what is an acute angle? So an acute angle is an angle that is between 0 and 90 degrees. It shouldn't be 90 degrees, but it should be greater than 0, like starting from any number greater than 0 up to 90, but not 90 itself. That's why I'm not putting equal to, it's just less than. So this kind of angles they are like that as long as it is not making 90 degrees. So as long as this is not 90, anything that is not 90, it is an acute angle. Okay. So from the acute angle now we have got a right angle. The right angle is an angle that gives us exactly 90 degrees. So like that, that's a right angle. That's why we didn't include 90 on the acute. So from the acute angle, the other one we need to get to understand is the obtuse angle. Now the obtuse angle is between 90 and 180. So you are going to see that angle like that. It's not making a straight line, of course, and it is going above 90. We know that 90 is like this, and then a straight line is like that. So any angle that starts like that and then comes there is what we call an obtuse angle, between 90 degrees and 180 degrees, but excluding 90 and 180. So from that we have a straight line or a straight angle. So a straight angle is exactly 180 degrees. That's a straight line like that, which is exactly 180 degrees. From that, what we have now is a reflex angle. The reflex angle is between 180 and 360. But we are not including 180, we are not including 360. So a reflex angle can be like that or like that, as long as it is greater than 180, or it can even be like that. All these are reflex angles as long as they are greater than this line. This line we can see here, as long as it starts from here and then it turns like that, this angle we can see, or it goes like that and then turns like that. So this angle we can see here. All those are called reflex angles. Alright, so apart from a reflex angle, the last angle that we want to look at is a complete turn, complete revolution, or a full rotation. So that is exactly 360 degrees. That's simply a circle, which is 360 degrees. So these are the angles that we need to get to understand. So we see that when we are measuring angles, we measure them relative from the positive x-axis going in the anti-clockwise direction. Anti-clockwise. A watch goes in this way, and so we call it clockwise. In the opposite direction, that's what we call anti-clockwise. So angles are measured in the anti-clockwise direction. If an angle goes like this, it means it's going to be negative. For example, if it reaches here, you'll see that it's negative 30. That means a positive version is supposed to be like that, starting from where it has started, going in the anti-clockwise direction to where the line is. So that is how we measure angles. So if we have got an angle which is here, so we are supposed to measure it from that point up to there. So it means if we measure this angle like that, then the angle is going to be, find it is going to be negative. Okay, you can find that it is negative. That is because we are measuring in that manner. But angles are supposed to be measured from this point like that. Alright, so that knowledge is very much important for us to understand, because there are a lot of various questions that can be asked just on that one. Okay, after having understood that, let's look at something here. Let's say we've been given, of course we've looked at spatial angles and I've talked about the quadrants. What if they tell us, let's say they've given us a certain condition. They say sin theta, which is equal to 3 over, we've been given, okay, given sin theta which is equal to 3 over 5, and then they say theta is in the second quadrant. So we want to find the, so they ask us find the value of tan theta and sec theta. How are we able to find those? So we've been told that this theta lies in the second quadrant. So if we draw our quadrants, so for this theta to be in the second quadrant, that means the angle that you are going to have is going to be there. Now, whenever we're measuring angles, angles are always related to the positive, to the x-axis. So if you have got an angle which is in this quadrant, the angle is going to be related to the x-axis. This is the x-axis. If you have got an angle here, the angle that you are going to have will be related to the x-axis, not this one. The angle we are talking about is the one related to the x-axis. So that means if it is here, which one is related? Is this one or this one? So the one related to the x-axis is that one. So what if in this region? Which one is related to the x-axis? Is it here or here? So notice that it is here. That's the one which is related to the x-axis. So whenever they tell us the quadrant, you need to look for the angle that is related to the x-axis in that particular quadrant that we are talking about. Alright. So they've told us that it is in the second quadrant. So it's in there. So of course, so the angle theta is going to be here. And then what we are having is, we have that. So this is the triangle that we have. Now I've been given that sine theta is equal to 3 over 5. And we know that sine is opposite over hypotenuse. So to the angle theta which we can see here, the opposite is the one which is on top. And then the hypotenuse is the one which you can see there. So the opposite, what is the opposite? The opposite is a 3, and then the hypotenuse is 5. Okay. So what we really need to find is the adjacent here. And how do we find that adjacent? We can use is the Pythagoras theorem again. Very important theorem to use. So we know the hypotenuse, we know one side. So to find the other side, let's call it x. So x squared is going to be equal to, get first the hypotenuse squared and then the other short side squared. So that will be x squared is equal to 25 minus 9. So that gives us 16. And we want to remain with x, so x is going to be the root of 16, which is 4. So the x therefore is 4 in that case. So we're going to substitute the other part, which I wasn't given, is 4. But remember, it is in the second quadrant. In the second quadrant, this is supposed to be negative 4. So negative is just telling us, just the word second. It's telling us the x value in the second quadrant is always negative. So if they told us it is in the fourth quadrant, in the fourth quadrant, x is positive, as you can see, x is positive, but y is negative. Okay, so we need to get to understand those. Now, we want to find the value of tan theta. So tan theta, we know that tan is opposite over adjacent. The opposite in this case is the 3. The adjacent is -4. So which you can also write as -3 over 4. And then we want to write sec theta. Now sec theta, we know that sec is a reciprocal of cos. So this is the same as 1 over cos theta. So which we can write as 1 over. Now how do you find cos? Cos is adjacent over hypotenuse. The adjacent is -4. The hypotenuse is 5. So that is what we are going to have, that which we can even write as 1 divided by -4 over 5, which gives us 1 multiplied by 5 over -4, which gives us -5 over 4. So that would be the value for sec theta. So basically that is how we determine them if we've been asked such questions. Alright. Now let's look at some other problems. So before I even look at this, I think we need to understand also a radian measure. How do we calculate in radians? What is a radian? So a radian is another form of measurement. It's another form in which we can use to measure angles, except using degrees. So if you've been given 90 degrees, if you want to convert from degrees to radians, what you get is just get a number, the angle which is in degrees, multiply by pi over 180 degrees. Just that, and then you would have converted. We know that 90 into 90 is 1, 90 into 180 is 2. So that gives us pi over 2 radians. So that is how we convert from degrees to radians. What if we've been given 180 degrees? How do we convert to radians? So that would be 180 multiplied by pi over 180 degrees, which gives us 180 into 180, that would be a 1. So that will give us pi radians. It's important for us to put this rad, because if we just write pi, what are we talking about? Because pi can be anything. Okay, it's important for us to just put that at least, because pi is also just a number. Alright, what if we are talking about 65 degrees? How do we convert that to radians? So that would be 65 degrees multiplied by pi over 180. So all we need to look for is a number that can go into 65 and into 180 without a remainder. So if we get 65 divided by 5, 5 into 65 will give us 13. And then 13 multiplied by pi. And then 180 divided by 5. That is going to give us 36. And we know that we can simplify this one further. So 65 is the same as 13 pi over 36 radians. Alright, what if you've been given, let's say, 210 degrees? We want to convert to radians. So that becomes 210 degrees multiplied by pi over 180 degrees. So that is going to give us, of course, this 0 can cancel with that 0. Now what number can go into 21 and also into 18 without leaving a remainder? So we see that I think 3 is able to, 3 into 21 goes there 7 times, and then 7 multiplied by pi. And then 3 into 18 goes there 6 times, so it will be 7 pi over 6 radians. So that is the angle now in radians. Alright, so that is how basically we convert from degrees to radians. What of the reciprocal? How do you convert from radians to degrees? Take for example, if they've given 5 pi over 3 radians, how do we convert that into degrees? So all we get is 5 pi over 3. We multiply. Now in this case we're going to multiply by 180 over pi. We just change. So notice that the pi and the pi cancels. 3 into 3, that would be 1. 3 into 18, that is going to be 6. And then we've got a 0 there, that would be 60. Then 5 multiplied by 60, that is going to give us 300. So 5 pi over 3 radians is the same as 300 degrees. Alright. What if we've been given 7 pi over 2 radians? What is this in degrees? So same, we're going to multiply the 7 pi over 2 by 180 divided by pi. Notice that the pi cancels, and 2 into 180 is going to give us 90. So 90 multiplied by 7, that gives us 630 degrees. So it will be 630 degrees then. Okay. What if we've been given 1.21 radians? How do we convert that to degrees? So same, we just get a 1.21. We multiply by 180 over pi. So punching on our calculator, 1.21 multiplied by 180, and then dividing the answer by pi, that is 69.32789,321, which I can simply write as 69 degrees. Okay, so that is basically how we convert from radians to degrees and such not. Now let's see how we can find the exact value if you've been given a certain trig ratio. Let's say they tell us find the exact values of the following. Alright, so let's say we've got the first one. They tell us to find the exact value of sine 60 degrees, and then also tan, let's say 30 degrees. Now these we already know, like these are special angles, and so we don't need to worry anything. Now if you look at 60 degrees is in the first quadrant. So 60 is in the first quadrant, and you know that in the first quadrant all trig ratios are positive, and so sine of 60 degrees is going to be equal to, we know that sine 60 is 1 over 2. Sorry, not 1 over 2. Okay, sine of 60 is root 3 over 2. And then 30 degrees is also in the first quadrant, and in the first quadrant all trig ratios are positive, and you know that tan 30 is 1 over root 3. So basically that is how we find on that one. So direct. What if they've given us to find the value of, let's say sin, can I say sin 210 degrees? Okay, what will be the exact value for sin 210 degrees? The first thing we need to understand is in which quadrant does this angle fall. So in which quadrant are we going to find 210? 90 is here, 180 is here, 270 is here. So that means 210 should be able to fall in this quadrant like that. So remember, we always measure angles from the positive x-axis in that manner up to there. So that is the 210. Now we want to find the acute angle associated with the x-axis. So what we want to get is, what is this angle? The acute angle associated with the x-axis, so that we use a special angle. So how do we get that angle? We know that a straight line here is 180, and then we know the whole of this as 210. How do we get that? So to find that one which is missing, we simply remove 210. From 210 we're going to remove 180. So what we are saying is 210 minus 180. This is going to give us 30 degrees. So that means this angle which we have here is 30 degrees. Okay. So after finding that, and then we're going to get our ratio. We are saying sin 210 is equal to, we're going to write it in terms of this special angle that we have. So the special angle is 30 degrees associated with 210. So we're going to say sin 210 is the same as sine of 30 degrees. Now we ask ourselves, of course we are in the third quadrant. We know this is all students take coffee. In the third quadrant, only tan is is positive. So that means we are talking about sin in the third quadrant. The sin is going to be negative. That's why we're going to put a negative there. So sin 210 is the same as negative sin of 30 degrees. So that gives us negative, but we know that sin 30 is 1 over 2. So sin 210 is the same as negative 1 over 2 without even using a calculator. Alright. So let's look at tan. What of tan 210? So same, this 210 falls in this quadrant, and then that is a 210. Now the special angle associated with 210, of course, we found that it is 30 degrees. Now we know that all students take off in the third quadrant. Tan is positive, so we're going to say tan 210 is the same as, what is the special angle associated with 210 in that quadrant where we are? It is 30. So it's the same as tan 30 degrees. Now notice that tan is positive in the third quadrant, so this will simply be a positive value. Okay. Now what is tan 30? So tan 30 is 1 over root 3. So that would be the exact value in this case, 1 over root 3. Alright. We'll go on looking at another instance. What if we've been given cos 300 degrees? How do we work out that one? Cos 300 degrees. Alright. So cos 300 degrees, what we are going to see is, let's first discover the quadrant. This is 90, this is 180, this is 270, this is 360. That means 300 should be somewhere here. So this is the 300 we are talking about. But remember, we need to find the acute angle associated with the positive, associated with the x-axis. So the one associated with the x-axis is that one. So if the O of it is 3, so if from the start up to where we've ended there is 300, and then you know that the complete revolution makes 360, what will be that acute angle? So it will be 360 minus 300, which is going to give us 60 degrees. Alright, now we know that in the fourth quadrant where we are, cos is positive, and so we're going to get our cos 300. So we'll say cos 300 is the same as cos 60. In the quadrant where it is cos is positive, and we know that cos 60 is 1 over 2. So that will be the exact value in that case. Alright. So what if we've been asked to find, let's say, tan negative 30 degrees? What will be the exact value for this one? So if we draw on our quadrants, this negative means instead of us going like that, we are going like that. That's the meaning of a negative. So we're going to make 30 degrees going in the opposite direction. So the 30 will be made here. So that is where it is. Now the reason as to why there is a negative is just telling us that we are going in the opposite direction. Otherwise, we're supposed to measure this angle in that manner. Okay. Now we're talking of tan negative 30, which we can also say it is simply the same as tan. The acute angle here is simply 30. Now we ask ourselves, in this quadrant where we are, all students take coffee. In the fourth we are in the fourth quadrant, and we know that only cos is positive, so that means it is going to be, the tan is going to be negative. So tan negative 30 is the same as negative tan 30. So that will give us negative. We know that tan 30 is 1 over root 3. So that becomes the value then. Alright. What else are we able to talk about? Let's say, what if you've been given sine negative 210 degrees? How are we able to find that one? So we are going to come on our quadrants. So if we start 0 here, the reason why we're measuring negative is because we're going in the opposite direction. So that means this is going to be negative 90, so become negative 180, so become negative 270. So we want negative 210. So negative 210 will be in this quadrant like that. It's negative because we are going in the opposite direction like that. So that is a 210. So I want to find the acute angle associated with the negative 210. So the acute angle which is related to the x-axis is that one. So all we are going to do is, from this one which we have, this angle which we have, we are going to remove a straight line, and then we are going to remain with that. So 210 minus 180. So that is 30. So this angle here is going to be 30. So that means sin negative 210 is the same as sin 30. Now we ask ourselves, what is sin in the second quadrant? Is it positive or negative? Now notice that sin is positive in the second quadrant, so this is going to be positive. And we know that sin 30 is 1 over 2. So we write our 1 over 2 like that. So then that becomes the value. Okay. So with all trig ratios, we can just work in the same manner. So say we've been given cos 11 pi over 6. What will be the exact value? Now in this case, we've been given the angle in radians. All we need to do is just to convert the angle into degrees. Okay. And how do we convert from radians to degrees? Just by multiplying by 180 over pi. So the pi goes 6 into 180 is going to give us 30. 30 multiplied by 11 is going to give us 330. So cos 11 pi over 6 is the same as cos 330 degrees. And then we're going to come on our quadrants. We see where 330 is. So 330 is in this quadrant, like that. So that is our 330. So what is the acute angle associated with 330? So the acute angle is 30 degrees. Like if we remove 330 from 360, what we're going to remain with is 30 degrees. So this is the 30 degrees, the acute angle associated with the x-axis. And so we are saying cos 330 is the same as cos 30 degrees. But in the last quadrant, fourth quadrant, is cos positive or not? All students take coffee. In the fourth quadrant, cos is positive, so this will be positive. And you know that cos 30 is the same as, okay, so cosine of 30 degrees is root 3 over 2. So then that becomes the exact value in that case. One more last problem. Okay. So let's say we've been given what of cosec 5 pi over 4. How do we work with this one? Now the first thing is, let's just convert first from radians to degrees. The 5 pi over 4 we multiply by 180 over pi. The pi goes 4 into 180. That should give us 90 degrees. I mean 45. And then the 45 we multiply by 5. That is going to give us 225. So cosec 5 pi over 4 is the same as cosec 225 degrees. But when we're talking about cosec, what is the reciprocal of cosec? It is sin. So cosec 225 is the same as 1 over sin 225 degrees. So now we need to go on our quadrant. We see the special angle associated with a sin 225. So this is 90, this is 180, then you've got 360, we have got 270, 360 is here. So 225 is between 180 and 270, so it is going to be in this quadrant. So the angle that we are talking about is here, that is the 225. So the angle that we want to find is the angle associated with the x-axis, the acute angle associated with the x-axis, so that's the angle. So what we are going to do is, from 225 we're going to remove 180. So that is going to give us 45. So this is going to be 45 degrees here. So that means 1 over sin 225 is the same as 1 over sin 45. But what is sin in the third quadrant? Or students take. So we see it's only term which is positive. Sin is going to be negative in the third quadrant. So we're going to put a negative here. And then we go on, 1 over negative. What is sine of 45? 45 is a special angle. Sine 45 is 1 over root 2. So we can also write this as 1 divided by negative 1 over root 2, which we can also say as 1 times the root 2 goes on top, and then the negative 1 comes down. So which is simply 1 times root 2 is root 2 over negative 1, which is negative root 2. So that is how we find the exact value then. So basically that is how we deal with all these special angles and radian measures. Okay. So in this video I'm going to end here. See you in the next video now, where we talk about identities and how we can use them with other forms of special angles. Alright, the same special angles that we've looked at, but how do we apply them when it comes to identities? Stay blessed.